Welcome to Module 3 Working with LLMs in LangChain. In this module, we are diving into the heart of the LangChain, connecting and controlling large language models. LangChain gives you the flexibility to plug into a variety of powerful LLM providers, not just OpenAI, but also Anthropic, HuggingFace, and many more. Whether you are using GPT-4, Claude, or any open source model like Mistral or Llama 3, LangChain gives you one unified interface to manage them all. Here is what we will cover in this module: how to connect different LLM providers like OpenAI, Hugging Face, and Anthropic, how to control LLM behavior using parameters like temperature, max tokens, and stop sequences, how to make API calls more efficient, reliable, and scalable. And finally, we will build a real world project, an AI powered resume analyzer that extracts key insights and evaluates a candidate's suitability for a role. By the end of this module, you will know exactly how to connect, configure, and optimize any LLM using LangChain, all with real working code. Now you are ready to unlock the full potential of LLMs in your apps. Let's jump in. So, which large language model should you choose? It depends on what you care about most: intelligence, speed, or price. Before we dive in, check out artificialanalysis.ai, a real time dashboard that compares LLMs across all three metrics. It's a must have tool for all AI agent developers and researchers. At the top in raw intelligence, it's a tight race between Claude 3 Opus, GPT-4 Turbo, and Mistral Large. These models shine in reasoning, summarization, and nuanced responses. Mistral, Llama 3, and Gemma are great mid tier options. They are faster and cheaper while still very capable. If speed is your priority, nothing beats Grok's LLM hosting. Models like Mistral and Llama 3 run sub 100 millisecond latencies, ideal for real time applications and chatbots. When it comes to cost efficiency, open source models on platforms like Grok or Together.ai offer huge value. Llama 3 8B, for example, gives impressive performance at a fraction of GPT-4's cost. Artificialanalysis.ai shows exactly how much you are paying per thousand tokens across models and providers so you can make data backed decisions. So, what's the best model for you? If you need deep reasoning, go with Claude 3 or GPT-4 Turbo. If you need blazing speed, go with Mixtral on Grok. And if you want the best value, try Llama 3 or Gamma. And if you're still not decided, visit artificialanalysis.ai to explore live comparisons and find the perfect LLM for your needs. In this video, we are diving into how to connect different large language model providers in LangChain, including OpenAI, Grok, Hugging Face, and Anthropic. Whether you are building a chatbot, an AI assistant, or a document analyzer, understanding how to integrate with multiple LLMs gives your app flexibility and power. Let's get started. LangChain uses unified classes like LLM and chat model to abstract different providers under a common interface. This means you can switch between OpenAI, Hugging Face, Anthropic, and Grok with minimal code changes. making your app future proof and multi provider ready. Let's start with OpenAI. Here is how you can connect to GPT-4 using LangChain's Chat OpenAI wrapper. First, you need to import the Chat OpenAI wrapper using LangChain. Once you import the Chat OpenAI wrapper, you can initialize LLM and you can pass model name and your OpenAI API key. Here you can see we have passed the model name GPT-4. Make sure your OpenAI API key is handy. Now let's talk about Hugging Face. The same way like OpenAI, first you need to import the wrapper class Hugging Face Hub. Once you import the wrapper class using LangChain, you can initialize LLM using the same wrapper class. You need to pass a model name. Here you need to pass a model name in repo ID. You can see the model name Flan T5 and you need to pass the Hugging Face API token. To get the API token, you need to create your account in huggingface.co and create the API token. You need to copy paste the API token and pass it here. This lets you work with models like FLAN-T5, Bloom, or even your own fine-tuned models. And finally, let's connect to Anthropic's Claude, which is known for its long context reasoning capabilities. The same way like Hugging Face and OpenAI, you need to first import the wrapper class ChatAnthropic. Once you Once you import the wrapper class, you can initialize LLM and you need to pass the model name and Anthropic API key. Using the same wrapper class, ChatAnthropic. Here you can see the model name Claude V1 and Anthropic API key. To get the Anthropic API key, you need to create your account in console.anthropic.com. Once you create your account, you can create your API key. Claude is a great option if you are summarizing large documents or need more thoughtful responses. Because LangChain standardizes the interface, you can switch providers like this. Here you have seen we can change the LLM using changing the wrapper class. You can initialize LLM using a different wrapper class and you can pass the model, you can change the model name and your API key. That's it. Once you change these three things, you can easily use different LLM provider using different LLM model. This flexibility allows for alpha beta testing across models, fallback logic, or even chaining different LLMs together. Alright, now let's jump into a live demo where we will explore how to use different LLMs through Grok Cloud. You need to create a Grok Cloud account and create the API key. In this demo, we will build a simple chatbot using LangChain and Grok Cloud, which delivers ultra low latency access to blazing fast open source LLMs like Mistral and Llama 3. Grok is a new interference platform optimized for speed, making open source models feel real time and even faster than GPT-4 in many cases. Using LangChain, we can easily plug into Grok's API, send user queries, and get structured responses. Now let's break down the code. In first step, we're going to import the necessary modules and set the Grok API key as an environment variable. In the next step, we're going to create the ChatGrok LLM instance and configure the model. In this case, we are using Compound Beta Mini. Next, we're going to set up the conversational prompt and wire it all into conversational chain. Once it's running, we can chat with the bot just like this. Here you can see the output. Chatbot started the conversation with the line, "Hello, ask me anything. Type exit to quit." The same line that we have defined in the code. I am giving the response, "Give me the list of models that I can use with Grok." Chatbot responded all the models supported by Grok Cloud. Now I'm asking the chatbot which one is the best for reasoning from the given list. Because I have not set up the buffered memory, it doesn't remember the conversation. So it asks me to provide a clear answer. I need to know the given list. I am providing the list saying the list for LLMs are Llama, Llama 2, Llama 3, Mistral, Gamma, Palm. Now tell me which one is the best for reasoning and summarization. Grok chatbot responded me with details about the large language models and also gave me the recommendation. For general reasoning and summarization, Llama 3 is strong candidate. For speed and efficiency, Mistral, sparse mixture, etc. And for lightweight applications, Gamma models. I am quitting the conversation by saying exit. Here, this is the output that we got from the model Compound Beta Mini. You can easily swap the models by changing the model name to Llama 38B, Llama 370B or Gamma 7B, and you can compare the output provided by other large language models just by changing the model name. In the next demo, we will look at how to build tools that go beyond chat, like an AI-powered resume analyzer. Now we are going to explore how to customize the behavior of your LLMs using key parameters like temperature, max tokens, and stop sequences. These settings give you fine-grained control over the model's creativity, length of response, and output boundaries. So you can tune your AI to behave exactly how you want. Let's dive right in. Different applications need different kinds of outputs. For example, a story generator may need creative, longer responses. A financial report analyzer should be short, concise, and deterministic. LangChain lets you customize the output using just a few simple parameters. Let's start with temperature. This parameter controls the randomness of the model's output. Zero point zero makes the model deterministic. It means same input equal to same output. Higher values like zero point 0.8 make it more creative and diverse. Use temperature zero point zero for fact-based applications and zero point 0.7 plus for creative tasks. Next, we have max tokens. This sets a hard cap on how long the responses can be. One token is roughly 4 characters or 3/4 of a word. Limiting this helps prevent runaway outputs and reduces cost. You can use you can use a lower max tokens value to keep responses brief, especially in chatbots or UI limited apps. Stop sequences are powerful tools that tell the model when to stop generating text. This is helpful when you are formatting output, preventing the model from spilling into unwanted sections. So you can combine all three parameters in one LLM setup. This gives you a controlled, focused, and formatted output ready to be displayed in your app. Tuning these parameters gives you precise control over how your apps talks to users. In the next slide, we are going to discuss how to handle API calls efficiently. Now let's discuss about handling API calls efficiently when working with large language models in LangChain. This is a crucial skill, especially when you are building scalable apps that rely on multiple or frequent API requests. Let's explore how to make your LLM integrations faster, cheaper, and more reliable. Every call to an LLM API consumes time, uses tokens, and can fail due to rate limits or network issues. LangChain offers several built in strategies to optimize these calls. Let's see top ones today. Let's start with caching, one of the simplest ways to improve performance. If the same input has been asked before, we can reuse the output instead of reheating the LLM. In-memory cache function will automatically cache responses in memory. You can also use Redis or SQLite for persistent caching across sessions. APIs occasionally fail, especially OpenAI or Anthropic under load. LangChain automatically retries on failures, but you can customize the retry logic using Tenacity. While initializing the LLM, you can define the max retries. If you are processing the multiple inputs, instead of looping one by one, you can batch them. This reduces latency and improves throughput since the multiple prompts are handled in a single API call. Next, we have got a hands on demo that you don't want to miss, an AI powered resume analyzer built with LangChain, OpenAI, and PDF parser. This tool extracts key details like skills, education, and experience, and even gives a suitability score for a software engineering role, all automatically, straight from a resume PDF. Let's walk through the code and see how it works in action. Mastery series. In this video, we will build a real world project, an AI powered resume analyzer using LangChain, OpenAI, and PDF parsing. This demo pulls real data from a resume and uses GPT to extract structured insights like skills, experience, and even assigns a score for software engineering suitability. Let's dive in. Let's begin by installing the required packages. We are using LangChain OpenAI, and OpenAI to interface with LLMs, PyPDF to parse resume PDFs. After installing, make sure your OpenAI API key is set properly as an environment variable. We will now load our model using LangChain's OpenAI wrapper. We are using GPT 3.5 Turbo with a temperature of zero point 0.7 for a balance of creativity and accuracy. Now let's get our resume data ready. First, you need to upload the resume into Files folder in the Google Colab notebook, and in the Content folder, you can click three dots. Once you click three dots, you will get the upload option. You can easily upload your sample resume here. Here I have uploaded the sample resume of Jane Doe. Let's move on. Once you upload your resume data will be available in Google Colab Notebook, and using PyPDF loader, you can make your resume data available in the notebook. Here we have combined all the pages of the resume into single string, ready for analysis. In the next step, we will craft a custom prompt. We want the LLM to extract name, skills, education, years of experience, and provide a suitability score for software engineering role with explanation. Now we pass everything into LLMChain, which handles feeding our resume and prompt to the LLM. Once the LLM chain is ready, we are going to run the chain and print the results. As you can see, model extracted the key fields and evaluated the candidate. Here you can see model extracted the key fields like name, skills, education, years of experience as mentioned in the prompt. You can see the output here. In the sample resume of Jane Doe, I have mentioned all the required information which is available in the output. Jane Doe, name, skills, active listening, negotiation, conflict resolution, communication, time management, etc. Education, LinkedIn learning courses, Tier 2 in general insurance, fitness instructor, etc. And the years of experience is 3 years. You can see it has provided the suitability score for software engineering role 20 out of 100, and it also provides the reasoning. The reasoning it provides is the candidate's resume mainly focuses on business analysis, project management, and customer service roles with limited experience or skills mentioned in software engineering. And while some transferable skills like problem solving and analytical thinking may be applicable to a software engineering role, etc. So that's why it provides the suitability score 20 out of 100. Perfect. This is an incredibly useful for HR teams, recruiters, or even the candidates self-analyzing their resumes. You can integrate this agent with application tracking systems, career portals, internet talent scoring tools, resume comparison bots, and you can even expand it to support job matching or convert this into chat-based resume assistant. That wraps up our AI-powered resume analyzer demo. Congratulations on completing Module 3, Working with LLMs in LangChain. You have just taken a major step forward in mastering how to connect and work with powerful large language models using LangChain. Here is a quick recap of what you have learned in this module. How to connect different LLM providers, including OpenAI, Grok, HuggingFace, and Anthropic. How to customize model responses using parameters like temperature, max tokens, and stop sequences. How to optimize API usage for speed, efficiency, and cost. And finally, you built your first real world LLM application, an AI powered resume analyzer. Now that you know how to work with LLMs, it's time to level up your prompt engineering skills in Module 4, Building Prompt Templates. In the next module, we will cover what prompt templates are and why they are essential, how to use variables in prompts to make them reusable and dynamic, techniques for designing effective prompts tailored to different tasks and use cases, and we will build a dynamic prompt based AI content generator in a hands on demo. Thanks again for watching and completing Module 3. If you found this content valuable, don't forget to like the video, share it with your friends and teammates, subscribe to the channel for more modules and updates, and leave a comment below. We would love to hear if these videos are helping you. See you in Module 4, where we will dive into the power of prompt templates and unlock the new possibilities with LangChain.